We introduced events at the person level for things like partnership formation and dissolution. There might be an event at the person level for something like a pregnancy. There might be an event at the person level for life course events such as marriage for a person and what have you. Those are events that apply to a particular person. In contrast, an event in Maine would be the sort of thing like immigration, where the person isn't around yet, we're bringing a person in and adding them to the population. I was hoping to talk just a little bit more about these sort of events to give you a bigger picture on that. Andre had noted, as had I in a previous talk, this notion of synchronous versus asynchronous models. So models that work in a series of discrete time steps, one step after the other, with everything updating in lockstep between the agents. That's a common metaphor you'll see in a lot of agent-based models, including some in AnyLogic. So if you look at, for example, the wandering eloquence model, you'll find that they get updated at a single time, and then updated at the next time steps. And in a system dynamics model, that is the typical mode of operation. You'll see the flows get computed, the stocks get updated, and then we go to the next time step, the flows get computed, the stocks get updated, the next time step, the flows get computed, and then stocks get updated. So time advances there in steps. And there's more and less sophisticated ways of doing it. The classic method is order integration. There's roughly cut integration, which can be fixed or variable time steps. But fundamentally, we have a very lockstep form where we compute all the things together. And in traditional agent-based modeling, and virtually all the popular frameworks that I know of and have tried, except for AnyLogic, this gives you a great deal of headache in agent-based models. Among other things, you have to figure out which agent updates before which other agent. If an agent, for example, has two types of processes going on, say on the one hand, a process of migration, another a process of infection, another process of death, you have to kind of, on each time step, figure out which of those is occurring, and suppose that death is occurring and infection is occurring, which occurs before which within a person. And it's actually quite a pain to have to worry about this sort of thing. And to have to make sure that the output of your model is not affected by the vagaries of which agent is updated before which agent. You don't want to have artifacts created in your model results that you think that you lend interpretation to, you lend meaning to, but they actually turn to be based on something very artificial, something synthetic, something that's just about the implementation, which person you update before which other person. Fortunately, AnyLogic, through the use of an event-driven scheduler, eliminates this, most of this from your words. There you have events occurring whenever, as Andre puts it, they need to occur. If there's a death event occurs, it occurs at a certain moment in time, whatever a moment is. If an immigration, or excuse me, if an infection event occurs, it occurs either before that or not at all. If a migration event occurs, it's either before that death event or not at all. Migration or infection, one occurs before the other typically. AnyLogic jumps not from time step to time step in some fixed way, but instead it goes forward however long it has to from the next event is scheduled. Maybe it's person A dying, maybe it's person B's immigrating, or maybe it's person C's infection. So when we have these different events going on, there may be long periods of time or short periods of time, long periods of stasis, short periods of bursts of activity. And that lends our model a great deal of flexibility as well as considerable performance gain, because we're not stuck in the sort of simulate the most detailed level needed for any process, which is often the trap one gets into with a model which is updated in lockstep, be it a system dynamics model or an agent-based model, or a discrete event model. discrete event by definition does not do that. But if you have going in lockstep and you have processes at different scales going on or different time with different time constants, often you're reduced to the lowest common denominator. You have to update it according to the fastest process. So we once built a very large-scale model of a certain country's national infrastructure, and they were very concerned about events that might play out within a day scale in certain rare cases that could do great damage to the economy. Otherwise, they were thinking about things which might take months, years to play out. Certain economic processes which you could at least simulate on a multi-day, say a week level. And the fact that we had to consider those things within a given day forced us to simulate at a very fine time set. Fortunately, with the discrete event modeling here, you don't have to worry about it. What's going on is there's a scheduler, and the scheduler handles events. So if we were to take a look at any of the models that we've run, for example, that SI agent-based model was the very first one we ran. If I were to run this here, you'll notice that there are certain features shown which are related to this scheduler. So there's certain reporting that goes on concerning events. Events computed, for example, are handled per second. So if we run this model here, you'll notice there's this events per second is reporting, how much work essentially is being done in terms of the events handled. So here's 5 events per second, 0 right now, 6 right now, and the infection is in fact spreading very slowly right now. For I think it was because I changed some of the parameters there, but it's a very, very slow spread. If I were to simulate it here at this level, the level of main simulation, where it spreads faster, and we'll see something in the order of at least tens of thousands, often greater than that, events per second being handled. Okay, here too, it looks like perhaps I modified the model to be somehow slower in its infection spread. I'd have to close it and go simulate it again. I'll simulate it with this one here. So in any case, AnyLogic is handling these large numbers of events, typically from second to second, and it goes forward. Those are sort of the units of calculation. So if I were to go view the time scale here, okay, yes, but I want to see events per second. Here we go. Events per second. Okay, so here it's 40, 30, 49, etc. In a larger scale model, it will commonly be hundreds of thousands. Here it's more limited by the size of the population. So we have the notion of a scheduler where it's scheduling all these events. It's keeping track of queues of events to handle. And we've seen a variety of implicit events, fixed rate timeouts, fixed rate events, timeouts, conditions, message transmission. Starting a model, stopping a model are associated with events. Maybe when you start the model, you want it to read in some data. When you stop the model, you want it to write some data out to a database or to a file. Generally, we term these implicit events because they're not they're not represented as objects. To handle these events, code is inserted in certain places. So, for example, we inserted code within a model in the startup event to do what? Does anyone remember where we handled the startup event for a model? Yeah, we seed people with an initial infection. There's also something called destroy code, where you might clean up certain things, write things out to a file, etc. So you can handle those events and do things at that time. So there's a variety of these built-in events, on message received, on arrived, all those sort of things. And they apply for many, many components. At any given time, the schedule is keeping track of a certain number of queued events. Events get added to the schedule as new things happen, like a message gets sent. That has to be handled at some point. A person enters a state. It actually schedules the events for leaving the state at certain times. And then sometimes events get deleted from the schedule. For example, when they fire off and complete, or when another mutually exclusive event preempts them. So when someone dies before they leave the state via another route. What I wanted to talk here about most importantly, though, is explicit events. Those are the ones we added earlier. So when we added an explicit event, for example, migration, we had an explicit event for partner change. These events can be declared from the palette. You drag an event, and there'll be several types of it. We're going to talk also about dynamic events, which are very powerful, can have multiple instances. They're one-time events set to go off a certain amount of time from when they're created. Okay, so explicit events occur with several variants. And one thing you got to be careful about is the rate at which they go off is, if it's dynamic, if it's changing over time, you may have to be careful about recomputing it. If, on the other hand, it's a static rate, then it's a straightforward thing. So that model that we had built, we just added an event with an average rate of 5, meaning 5 times per time unit it goes off. In that case, it's a very short event. Let's take a look at some of the other options. I'm just going to drag one here or into the model for a moment and call it event, but you'll notice there's a set of options with it. The trigger type for the event can be rate, as we saw earlier, but it may also be based on a condition, so a certain condition is reached within the model, or at a certain timeout. And this timeout means there's a precision with which the time it goes out. So it can either occur once at some delineated time, or it can be cyclic, where the first occurrence occurs at a certain time and then there's a recurrence time. So if you want a reporting event, for example, that, December 31st midnight reports some statistics on how many people are in the model are infected, you could do that using that event. And it would print out information on people's current status. So adding an event, print out aspects of status. I think what I'm going to do is just to demonstrate that in one other feature of AnyLogic, I think what I'll do is ask you to load in a separate model, which is provided to you. And it's a model of SIR infection spread over a network. Okay? And we're going to add an event into it that's going to do reporting of statistics on the population. Okay? And this is a common need, and I'm trying to hit two things at once here. So I'd like you to go open up a model of my examples we provided to you, rather than AnyLogic provides. An example model called, I think it's called, I'm just looking for it here. It's called, I think, Simple SIR or something like that. Minimalist, it's called Minimalist SIR Network ABM. Okay, so this is a predefined model, very similar to the one we've created with infection spread. I'd like you to be able to see this, so we have a common baseline to perform a change. So I've just loaded in this model. Does everyone find it here? It's in the list of examples. Okay. So let's run this model just to see what it does. So we're going to run it. There we go. And this should be familiar. Infection spreads among the agents. This is very similar to what we've done. We have susceptible, infected, recovered in green, red, and gray, respectively. Okay. So let's just open up this model to the main class. Well, let me ask this. Suppose I wanted a reporting event. I want to report on the statistics of the population, say the number of infected people at a given time. Where would I put that event? Would it go in each person? It's in main. I'm looking for it not to go off on each person separately. If I did want that, I'd put it in the person. Instead, I'm looking for it to go off across the model as a whole. So here we have it going off we want it to go off in main. So let's drag an event over there. And we call this reporting event, okay? And we'll have it go off with a certain regularity. Therefore, would it be a timeout or rate? If we want it to go off exactly a certain amount of time from each other, would it be in the timeout or a rate? It's timeout. It goes off. A rate is memoryless. It's associated with an exponential residence time. The chance of it occurring within the next unit of time is independent of the last time it occurred. We want this to go off exactly every year. The chance of it going off in the next time unit is hugely dependent on when it last went off. So we dragged in this event. We want it to be a timeout. It occurs once and occurs cyclic at time 0 and then every recurrence time of 1. Okay? Say it's a time unit of year. If it's not, I can make it 365. I'm going to do it for 1 just so we can see it very clearly. Okay, here's our event, and it's going to go off. Now, what's going to happen? Well, it's going to trigger an action. We want it to report the number of infective people right now. How are we going to do that? Well, I'm going to introduce statistics. So if you go up to population here, you can go to the statistics tab. And this is where we can define statistics on this population, how we collect certain statistics. Now, from a system dynamics perspective, these are all what I'd call sort of stock statistics. There's statistics about the model at a instant in time. And that instant in time. If we want flow statistics, like how many people got infected over the last day, we actually need a somewhat more mechanism. Okay? But statistics here are useful. Statistics are about this current point in time. They're useful. So I'd like to actually add a statistic and show you how to do that. So add a statistic in and give it a name. Give it count infectives. Okay? Machine is slow to a crawl. Pardon me while I go and check if anything obvious is up. Okay. No, it looks like maybe it's just thrashing. Okay. So here's our statistics. So I went to the population, I went to the statistics tab, and I did add statistic, and I declared count infectives. And I want to count here. I want to count people who match some condition. Notice there's this little light bulb that says use item to meet the embedded object. Can anyone de-geek that for me? Can anyone de-geek that? What does that mean? Item is the embedded object. Anyone guess? Sorry? Yeah, it's iterate. So item here is going to represent each successor person in the population. It's going to count. It's going to run some expression for each person. It's going to run some expression that tests whether a certain thing is true or false. It's going to count up the number where it's true. Alternatively, we could do a sum. We could sum up incomes across the population or wealth across the population. We could take an average income. We could take a minimum or maximum. AnyLogic provides all these for us. Okay? And it's actually pretty darn useful. These won't be computed every unit of time. We have to call it and we say compute, and it will go compute it. We're going to have to say count infectives, and it will count the infectives. Okay, so what will be the condition here for someone to be infective or not? Can anyone express it to me intuitively? How do we know a given person? Suppose I say, I'm a person in the population. You have to determine if I'm infective or not. How would you do that? Sorry? Their state. You'd look at their state. You'd look at their state. So we have to ask what's their current state. So here, they're named as item. And for a person, if we go look at this, they have a state chart called infection state chart. Okay? And I'm going to ask if I look at infection state chart, here there's a thing called infective, which is a state indicating they're in an infectious state. They can pass on the infection. They're shedding. So item. So I'm going to ask the state chart, hey, are you in this infective state? Does that make sense? Okay. So I'm going to say, hey, are you in this infective state? So I could say item dot, because it's that person state chart, I want to ask, dot infection state chart, okay? And then I want to ask, hey, is a certain state active? Is state active, okay? Now it's demonstrating, exhibiting truculence here. So is state active? I believe that's the syntax of it. I misspelled it here. That's why it was truculent. And is state active? Is state active? You see that's it's there, and I'm going to pass it the name of the state. Now I wish I could just say infection, but I can't. Infective, but I can't, because it won't know where to look for infective. It doesn't say here in main. It doesn't know where to look. It's too limited for that. So what I have to say is actually person.infective. Person.infective, okay? Because it's infected with respect to, I'll put this up on the big screen here so you could see it. So in the condition, this is what I'm writing. Okay, boom. Oh, what a thing of beauty. Moving right along. There we go. Pardon me, I'm going to just restore that thing of beauty just so I can keep it around. Okay, so here we're going to have item. That represents the current person dot infection state chart. That's their state chart. And then I'm going to, so that gives me a reference to state chart. Then I'm going to ask the state chart, hey, it's a certain state active. And what's the name of the state? It's person dot infective. That's the name of it. It's infectivity with respect to person. Why do I have to say person? Well, there's many layers of reasons, but one reasonably good reason is, suppose there was a person and a deer. A deer could be infected with CWD, and a person could be infected with some conditions. Maybe there's a different notion of infectivity, and maybe both. In both cases, they could be infective. And I want to specifically say I'm looking for person infective. I don't care about deer's infectivity. I'm asking about person. So item.stateChart.isStateActive person.infective, okay? This is just a name for the state. It's actually just a number. Just a number for the state. And it's asking, hey, is this person in that state? Does that make sense to people? Can I answer a question about it? So that's gonna, what is that going to return? The is actually the giveaway. In Java, this is used to indicate something that returns, anyone have a guess? Boolean, true or false. It's going to say true or it's going to say false. And the way in which this statistic works, it counts the number for which it's true. Okay? So in other words, it's going to be running through each person in the population. And for each person, it's going to run this expression. But before it runs it, it's going to make sure that item corresponds to that person. So for the first person in the population, person at index 0, it's going to run this thing, get their state chart, say, hey, are they in the state? And it's going to say, no, sir. And then it will go on to the second one. The person at index 1 in the population will say, hey, give me your state chart. And then it'll say, it's, hey, the state chart, is this state active for you? And it says, yes, sir. And so then it will count that up, etc., for each person in the population. Does that make sense? Is a state chart object. So this state chart within person is called infection state chart. That's its name. That's its name. And that's why we're directing our questions to it. And that's why previously when we infected, remember when someone received a message that said, in fact, we passed it on to infection state chart, for example. So if we go to person here and we go to age, we'd actually see before that when a message was received, we could actually just do it here, but in earlier versions of AnyLogic, you had to actually say, you actually had to say, hey, infection state chart, you get this message. So delegating it to handle it. And in general, if I had more than one state chart, that handles messages that have to figure out, oh, this message, that goes to you. This message, that goes to you. I pass it to the state chart. This is an object. We can have a reference to it. And then we can interrogate it. We could say, hey, what's your current state name? Or we could say, hey, is this state active in you right now? Does that make sense? So each person lying within each person in this model is a state chart. And ladies and gentlemen, that forms their heart. It's their beating heart in this model, as it were. And it beats with the pulse of infection and recovery. Just like that. Yes?
I thought the person that the state chart is always active because the person is in one of the states. So you're actually only counting the effective.
We're only counting the effective because the goal of this thing, it's a great question. The goal of this is to count infectives.
But you is asking whether the state chart.
No,
You're not asking whether it is effective.
no, that's why we pass it this infective. So this is a method called isStateActive, and for it to do its job, it actually needs the name of a state. See this? If we go here and we look at this, it'll say this is the specification associated with this method. It says returns true if the state chart is at the specified state, i.e. exactly in the state for a simple state and one of the inner states for a composite state. And it returns true if the state is currently active. Okay, so yeah, why item? It's actually, so it's going through each person in the population that's going to be running this little bit of code, right? And yet it has to run that little code for that person. It has to make sure it applies to that person. You'll notice that it gives this little hint in the light bulb. It says use item : the embedded object. So that's how you refer to its item. Because surely this condition as to whether or not a person is to be counted must depend on the person. It must depend on something about that person. So we have to be able to refer to that person. It has to be able to give us a reference to the person, and we'll tell it in return whether or not the person is worth counting or not. And in this case, this is the condition that tells us whether or not that person is worth counting. And to refer to the person, we call it item. And it's going to run this and successively run this code with item being each successive person in that population at time in turn. Now, can I show you something secret? Yeah. Correct. Well, you should get the count of the total population. Yeah. Or if you did true or something like that, you'd also get it. But yes, that's correct. But I'm going to show you something secret, if I could. Is that okay? Shh. What's that? Well, we got to watch it. Andre doesn't come back. Maybe you could guard the door. I'm going to do Control J here, and believe me, this is not about how to break the license. I'm not going to tell you how to do that. Well, never mind. Yeah, computer scientists can do many things, but we know how to do many things that are not ethical, but we avoid doing them. And you're not going to be able to extract things from me. Here we have count infectives. This is actually the code that does the work. So I just went down from that to see what code is actually AnyLogic produces from this. Okay, so under the covers, this is what AnyLogic produces. And this is not a grand secret, it's just most people don't commonly do this, but it is provided by AnyLogic. You just press Control J on PCs and it will go down to it. And you'll notice what it's doing. It's just looping over all the members of the population, calling each one item, and then it determines whether or not that the certain state is active, and if so, it increments a value, and then it returns this value. The value started at 0. So this is the count of things seen thus far. For each person in the population, it figures out whether or not they're infective, and if so, it increments that value and returns that value. Does that make sense? Does that make sense? Okay. Yes. Yeah, I'm going to close that. Item is a person. It's a reference to a person. Yeah. The second. Oh, you mean person.infective, this thing?
Yeah, they have
Yeah. Oh, well, okay. There's a.
Then when you run into AnyLogic, it doesn't work.
Okay, you're saying like this? Okay, well, okay. We have to be very careful here. The issue here is that so sometimes you may want to refer to item elsewhere here. The fact that we're referring to person is a reflection of the fact that infective is something it's a value that it doesn't change on a per person basis. It's defined by personhood, and so this is a reference to the name of the class. This value is what's, and I hate talking about this. It's one of the shortcomings of running atop a general purpose programming language. But this is what's called a static variable, and what it means is it's an attribute of personhood. It doesn't vary per person. Now, if you wanted a person's income, if you wanted the income of, we'd actually have item.income, because that's a characteristic of the particular person. It turns out that the names of states, by the way, AnyLogic defines them, are attributes of the class. And so this is how you have to refer to it. It doesn't belong to it's not like each person goes around and has a separate secret value infective of that constant. That constant is a feature of, is a characteristic of, is a property of, is associated with the notion of personhood, not a particular person. It's kind of like each of us may have, I don't know what you have in Australia, but we may each have an HSN, a health services number, or probably something similar, or something like a social insurance number, or what have you. We each have that. On the other hand, there's certain constants that are set on an entire, countrywide basis. The definition of a kilogram or something like that. You don't ask each person, what's your definition of a kilogram? That's something that's set by, standards of weights and measures as defined by the appropriate governmental department. In fact, by international standards. So, infective here is not a characteristic of a person. It's a characteristic of the class, and that's why we had person infective. In other cases, we might ask item.income or item.sex or something like that, and it's a characteristic of that particular person. Does that make sense?
Yeah, no, I understand. So it's like the female and male.
Precisely. Female and male was a characteristic, it's a characteristic of the sex there, and that sex was defined and associated with person. It wasn't associated with a particular person, it was sort of a concept associated with personhood. So that's why you'll sometimes see item over here. It's not so much that it's doing anything weird. It's just that's sort of where these state chart constants are defined is associated with person. I didn't set that. It's an aspect of how AnyLogic does things, but it makes sense from sort of the implementation standpoint. That makes a world of sense. I know why that is. Jeff, yes?
You could say item is an instance.
Item is an instance. Item is an instance of person class. The person class is the mold. An item just refers to as a reference to one particular instance of it, one particular object that it's like one cookie made from the mold. There's many other cookies around made from that same mold, and each of them has different sprinkles atop them, and they differ in their attributes. Item is referring to one particular cookie. This is asking about a characteristic of the mold, of the sort of thing that was used to produce them, a personhood, rather than some particular person. Does that make sense? Because we're asking, are they in this state? This person.infective is referring to the name of the state. And we don't want everyone to be going around with a different sort of way of naming that state. That state has one name that carries across all the different instances, all the different people, all the different objects. And we're referring to that one name for it. Does that make any sense? And if any of you are interested, if you were to go look at the Java code associated with person, and I know I'm speaking to a diverse audience, and some of you maybe, find this less appealing than take out the garbage. But here it refers to final short. These are actually the names right here. States of all the state charts. This is the code that's generated by AnyLogic. And the fact that it says static is why it's a characteristic of personhood. But it makes sense that it should be. I mean, that they've done a good job in doing that. Sorry to make you whiff the garbage. Okay, so does that make sense? Okay. I'm sorry. I wish I could hide this, but I'd be fooling you if I let you know. If I were to tell you, you don't have to worry about this sort of thing. You occasionally do have to worry about it. And that's why you want reference to a Java person if you need one, to kind of figure these things out. And that's why it might actually, if you've got really serious about this, it might behoove you to take a look at some of my Java for AnyLogic tutorials, just so you're not bowled over by these sort of things, okay? It's actually not that, believe me, I know you're afraid that you may have to learn all of Java. No, you don't have to. But you want to be comfortable with a small set of things. And this happens to be one of them, because it's something that's used a lot. Okay, so we have defined a statistic that basically asks each person, asks the population how many people are infected. Having defined that statistic, we then report it. So let's go back to our reporting event. And where are we going to report it? Where would we put the code to report that statistic, to print out the number of people that are infected? Sorry? So where are we going to put the code? So if we want the reporting event to do something, if we want it to print something out, we put it in the action field. So when it fires, do this action, undertake this action, perform this action. So down in the action field, do you remember the thing to print something out? Do you remember what I wrote? Trace ln. Means there's a new line after it. There's sort of carriage return a new line, so it goes down to the next line. Okay, trace ln, and I would say the count of, obviously we could put anything here. The count of infectives equals, and then this is the trick, folks. I have that statistic associated with the population. That statistic becomes a method of the population. So how would I call a method of the population? Sorry? Yes, dot something. That's absolutely right. What goes before the dot? Population. And actually, population is something that's in me. So just to be pedantic, I'm going to put this dot population. To make it clear. Okay, my population, I'm main. I have a reference to myself. I get my reference to my population. And now I can ask my population count infectives, whatever we named it. And I can just call that. Now that's now a statistic. It computes that statistic for us, okay? When we call that, it goes off and does that whole computation. It goes through each person in the population and says, are you are you suitable? And that it runs that little bit of code and it says, no. Next person, are you suitable? No. Next person, are you suitable? Yes. Where the suitability here is defined by who's in what state. Okay. Leonard. So the fact that we define this as a statistic meant AnyLogic turned it into a method automatically for us. It automatically takes care of making it a method. Does that make sense? Yeah. Okay. So can we run this? Okay. Okay. So okay. Okay. So here we go. It's running. Where's it putting the information? Anyone see it? Aha, indeed. Okay, so here we go up to the console log there. I'll drag it down here. Boom. Okay. Here it is. Count of infectives equals 1. Count of infectives equals 14. Count of infectives equals 13. Count of infectives equals 2. Okay, so here we have these successive infectives reported. Now, it would be kind of nice, don't you think, if it reported the time with it? So it's time this many, that time that many. So why don't we go back up to the reporting event, and we could just put, at time equals plus, and we just call time the count of infectives equal, and again, this is this dot time, it's the current time. Okay, so here I'll put this up. Sorry, I know it's hard on the eyes. There we go. So all I have is these quotes plus that again concatenates, puts the strings next to each other. Time, the count of infectives equals. So this is a quoted thing. This is a quoted thing. This thing is just called. This thing is just called. So these things call and return a value, and it gets turned into a string and pasted in. Does that make sense? Are people comfortable with that? Are people comfortable? Okay, so let's just try running this. Now, having made that change, you'll notice other things are being printed out there from other places, and it's kind of nice to sometimes clean up after a while so that you don't. Okay, so I'm printing it out, and here we have time 1, 2, 3, 4, 16, 17, 18. You see that? So it's printing out there these successive names. So here it's doing this count of infectives. Okay. So that was reporting with. So that's with a fixed timer. Okay. Those are two very common types of events: fixed time between events and events going off with a certain rate. Okay. Yeah. Yeah. Sure. Would you like me to do that? That might be a good exercise. Sure. Let's do that. Yeah. No. I think it's a wonderful idea. Okay. So, folks, how would we represent it graphically? Does anyone remember way back when we did something like that? It's actually just yesterday. Sorry. We added a chart. So we go down to the analysis, and then we go do time plot. I know, many nums ago. So we go down there, and we drag over. I think Jeff is having a good time this event. Okay, so we dragged in a time plot, and let's name it. Well, we can keep its name as plot. That's okay. How are we gonna get it to display something? So we've selected this. How do we get it to display something? Yeah, add the data item. We have to tell it what to display. And in fact, there could be many things. So we'll just add item in. And it will then ask us, do we want to display a data set or a value? We're going to say a value here. And what value? Okay, so folks, suppose we want to display the number of infectives over time. What value are we going to put in? Well, how do we we're going to give it an expression, a formula, secretly a bit of Java, by which it computes a value. What's that expression going to be? Yeah. Well, succinctly put. That's right. So the value is, okay, this dot population, just so, okay, this dot population dot, yeah, count infectives. Okay, it's count infectives, I think, or is it count infective? Okay. Okay, it's an unhappy camper with this. Population cannot be resolved. Oh, sorry? Oh, yeah, there's graphic in that. Yes, yeah. Yeah. I know why that is, Cleve. That's a very, oh gosh, that's really, I don't like that because it makes you people think weird things are going on, and there's a good reason for this, but it would be uncomfortable to explain. So we're not going to explain it, but yeah, it's just population, not common effectives. Well, yes, refer to the plot. So how do I know this? I know this. I mean, we could Control J and we could see the truth, the ugly truth revealed. So this is where the code is going, and what is it in? Like, what's the class that it's in? It turns out this refers to whatever class it's defined in. And if I scroll up here, no, okay, no, this is, oh, okay, sorry, yes, right, okay, yes, it's because, oh gosh, yes, yeah, exactly. So, oh gosh, don't force me to tell you about that. So it's using an anonymous class. So it's creating a data set secretly, and the data set has this code as part of it. And so this actually refers to the data set in that context. This is a somewhat shocking aberration from what's normally possible, but it is true that you can refer to population. It will know what you're referring to. And there's actually another way through some syntax I could get to it through this, but basically it's referring to a data set that's associated with this little accumulating this little value. Okay, I'm sorry to say that, but this is just one of those things where it's not worth pursuing. It works with population, and you can kind of leave it with that. It would probably take a day for me to fully explain it. Maybe there'll be left when I finished. So, for those who would be left would be real good folks. Salt of the earth. Okay, so let's run this thing now. So let's run this. We're gonna run it. They either be in bed or they'd be asleep. Okay. That's right. Okay, so we're running this now, and now we see this graph per Robin's request. Do you see that? Yeah. So this is a count of number of people effective over time. Okay. Nicely, you could right-click on it and do copy, and once you've done that, you could go into Excel and paste, and here's the data from it. So that's kind of a handy. It doesn't just come with this graph itself. There's the capacity to export data. Okay, so I've tried to address Robin's question with that. Hope that's sufficient. Okay, let's just talk about though different types of events. They can go off at a specified rate, Poisson arrivals, memoryless, with a fixed rate. You can have a rate that changes over time. You just got to make sure they kind of wake up and realize that. I won't go into that. One-time events that go off at a particular time. Some cyclical with precision precision timing between the events. Timeout. That's what we just put into place. Every year on the year it reports things. When a Boolean condition changes, like when a stock reaches a certain value, an event will go off. For example, a stock of virions reaches a certain value, the person dies. The event can go off. Or you can do it manually to sort of schedule an event. Okay, the final thing I want to talk about here are dynamic events. Like the types of events we've seen, a dynamic event is associated with an action that invokes when it occurs. Now, I personally don't like the terminology they've used for this, but I have to admit it's not terrible terminology. It's just, it kind of gets in the way of communication with their desired audience. Because dynamic to modelers has a connotation of changing over time, behavior over time. Here what dynamic means is it's using a computer science sense of dynamic, which has to do with when you figure out, in this case, when you figure out sort of how many instances of there are, it's figured out when the program's running, when the model is running, not beforehand. So a dynamic event is associated with an action, and it goes off a single time. It has a single associated schedule with it. Okay? You can think of it like setting up a little beeper that's going to go off at a certain time for you. It's like when you're baking a cake, say, you set up a timer to go off in 45 minutes, and then in 45 minutes it goes off. And you can imagine setting up a timer on your stove to do that and turn off the oven in 45 minutes or something like that. And it's just like that. You set it up, okay, 45 minutes from now, go off. Okay. Now, dynamic events are particularly flexible because you can have many copies of them. So it's like you have arbitrarily many timers at your disposal. You could set one up for the oven with the cake. You could set up another one to wake you up at a certain time in the morning. You could set another one to go off and start the car, to warm it up. I guess it's not a problem you folks have, etc. Each of these instances can be scheduled at a different time, and they can all proceed in parallel, and then they disappear after they fire. It's like the little timer vaporizes. Once it goes off, that's it. Okay. Now, what happens is you create the event at one time, anticipating when it's going to need to fire off, and from then on you don't have to worry about it. It's just going to be there. It's going to go off at the appropriate time to do the right thing. So there's some classic examples of where this is useful. And one point of this is very, very important. Frequently, the action we want to perform when it goes off depends on some context known to us at the time it expires. So we know what it has to do at the time. We know the oven has to be turned down to 200 in another 45 minutes. So we set it up with that information now, and then it does that job later. We set the thermostat so that in 3 hours' time it goes down to 15 degrees or what have you. Celsius, not Fahrenheit. So here we provided information ahead of time when we first create it, and from then on we don't have to worry about it. We know it has all the information it needs to do its job when it finally wakes up. Okay, now why would I use these? Yeah, I guess I could just sort of drag something in and show you what it looks like. So you'll notice if I drag in a dynamic event here, what I actually tell for it is I actually I tell it about some parameters, and then I say what it should do when it wakes up. These parameters, that's what I give it when I first tell it, okay, I set you up so you'll be ready to go off in a certain amount of time. And I give it all the information it needs. What's the information it needs? Well, that's specified in the parameter. Maybe it's what the baby's name will be. Maybe it's who the baby's father will be. Maybe it's, where the conception took place, whatever. The aspects of context. So if you're going to have a deer, for example, we have a chronic wasting disease model. Suppose we wanted to schedule deer births, and deer are in gestation for a prolonged period, and we want to set up a dynamic event to schedule a deer birth at the time of the mating event. So at the time of the mating event, we know who the father is. We know where the mating took place, the latitude and longitude. We know, perhaps we predetermine what the genotype of the baby is or what have you. And then we have an action that will go off when the baby is born. Okay? So in other words, we provided, when we first created all this information, when the mating occurs. And from then on, it's just waiting there. It's waiting, like that timer, to go off. And when that timer goes off, it has already, we have provided the information way back when we set the timer. So when the timer goes off, it can do its job. It can create the baby. It can create the deer. One of the places this is really useful in health modeling, ladies and gentlemen, is if you have statistics, say, on the number of people that immigrate, say, to Australia in the course of a given year with certain characteristics. So maybe for each successive year historical time that your model is simulating, maybe in 2003 we had this many immigrants with these characteristics, this other many immigrants with those characteristics, but we don't know exactly what day they came in. All we know is the year. And so when it comes to the beginning of the year, you will use dynamic events. You'll create a bunch of dynamic events, one for each of those immigrants. Schedule them at a random point during the year. You don't want them to all come in on January 1st. That could create weird aberrations. You kind of spread them out evenly between the year. And you create a dynamic event. And when you do that, you give it all the information you need, maybe the ethnicity, the age associated with the person, maybe some aspect of their educational status or whatever. And then that dynamic event is just waiting. And sometime during the year, as specified at the time it was created, it will go off. Boom. And that person will be added to the population. So that's a way of taking in data, which you know only for the entire year, and turning it into a set of events which will end up firing off during the year. Just waiting to happen. And you don't have to worry about it after you set it up. Very beginning of the year, you give them all the information they need. You send them off like floating a hat down a river. Okay, that's not. You can try to figure out how to turn that. So when the hat reaches its destination, it will do its job. It'll be warm. Sorry? Well, it won't say. It'll be used. Yeah. Oh yeah, you can do whatever you want. Yeah, it's just when you have this, it's really best suited when you have this separation between, you know now that you're going to need to do something a certain time ahead, and you have all the information you need to do it, or at least a lot of the information you need to do it now. So you schedule it, you know when it will be, so you schedule it, and then when the time comes about, it uses all that information you gave. Maybe it collects some additional information now, and it fires things off. Yeah. Yeah, for example, yeah. So the baby's characteristics might depend on the vagaries of the temperature of the time it was born. So there might be a risk of frostbite if it's born, in unseasonably cold weather. But it would also have at its disposal information passed to at the time the event was scheduled, at the mating time, which included the latitude and longitude where the mating event took place, the identity of the father, and all that sort of stuff. Does that make sense? Yeah. So again, separation between when you know what you got to do and when, and a bunch of the information for that, and you know ahead of time when it's going to be scheduled, and you just set it up, and then when it comes about, it will do its job. Okay. So it's a one-time event. It disappears after that. In this case, it adds the deer to the population, and from then on, it's done its job. Its job in life is done. It exits the scene. Does that make sense? Okay. I'm not going to belabor that point. I have two examples on sort of uses of this which I've provided, and they may be worth remembering. So one is this sort of mating of deer. Another is individuals in a population over time intervals, like these count of immigrants. We commonly when they're really really useful. We have used them to good effect, and they're very handy. Okay, so those are my comments on dynamic events. I want to comment a little now on the on mobility and spatial pattern. I first want to talk about space and sort of spatial space layouts, how AnyLogic supports it. And I have to apologize because I should have. I thought I had a separate lecture on it here, but I'm going to have to. Yes, please. Oh, sorry. Oh, I'm sorry. My enthusiasm. No, thank you, Jeff. It's much appreciated. This is indeed, yeah. So thank you. They're probably not interested in dynamic event. I guess so. It went off at the wrong time. Yeah. Okay. Great. Thanks. No. It's great. Thanks, Jeff. Yeah. Oh, yeah. That should be person not working.
Yeah.
That's a mistake.
That gave me a big headache.
That's a mistake in their documentation. It's
So
not.
you put item,
It will not work. No, it definitely won't work. Yeah. Yeah. Yeah.
The tutorial about Java for this AnyLogic.
Yeah.
Is it in the stick, or this is in a separate?
Yeah,
booklet?
I think they're in the stick. They may be in a separate folder,
Okay.
but I think I included them in there. Yes.
Mhm.
Here. Oh, I think I have my stick. Thought I had the stick. Is it here? No. Do you happen to have this? Oh, here it is. Okay. There we go. So let's check it out. Yeah. I haven't looked at this, what Jeff put together on it, but I gave it to him, I believe, as part of the. Okay. Okay. So let's take a look. Okay, let's remove this. I think.
I apologize asking questions
No.
about programming.
No,
because
no.
My background is
Math.
Yeah, and it's more differential equations.
Oh yeah.
I studied at Northwestern and in theoretical and applied mechanics.
Oh really?
So I'm really, I learned all of this finite element analysis
Yes,
things.
yes,
but
yes.
not much this. And later I was
Yeah.
working this software group mostly on process improvement and project management.
Uh-huh.
So although I'm teaching software engineering, but
Yeah.
mostly on the human or process and project management aspect
Right.
instead of programming aspect.
Yeah.
This is really good to to get me really on board with some of the programming things.
Oh, yeah.
Yeah, it's really good.
Well, hopefully it will be useful. So I'm just looking in here. Stocks and flows. Okay, it looks like he didn't provide for what reasons. Looks like this wasn't. So what I could do is I could put it on here if you'd be interested.
Yeah, I can, or I can give you, or I can put a computer, you can just put something there. Yeah,
Sure,
or- yeah.
sure. If you'd like to do that.
You
Uh-huh.
have a break.
Well, I'm doing okay right now. Thanks. Andre's going to come in about an hour and take over. So,
So if I want this, I think the other day
Yeah.
so you can actually lay out and put it somewhere else.
Yeah,
So
that's right.
So the reason that is by default. or is
No,
it-
no. It's just because we dragged it there, but
Did-
you can.
Did we? Wow, we dragged it there.
Well, in other words,
Okay.
when you dragged it in, you put it somewhere, and that's just where it
Okay.
where it goes.
Oh, okay.
So
Yeah. I think now I remember.
So you can drag it, elsewhere and
this,
so on.
Yes, this is the canvas.
That's the canvas. Yep. That's right. So that's where you put. Okay. So let me just go get these the most recent version of these guys. I'm just trying to think, because I actually did collect these for somebody just recently, and I want to be sure I give you the latest, the very latest version. Okay. Right. Lecture slides. Java tutorials. Okay. I think this is 1, 2, 3, 4. Yeah. Yeah. Okay. And here's, oh, okay. Would you like me to put that on there?
Yeah.
Sure, sure. Okay. Yeah. Yeah, I started putting these together just because some people really wanted an introduction to Java for it. And some of them go into more detail than you may be interested in.
Yeah, that's okay, because if I don't, I have access to expert.
Yeah.
I'll just
Yeah.
send it to
Sure.
a bit, so that,
Yeah, you bet. You bet. Yeah, there's some new features of Java that have come in over the years, and it's good to kind of know a little bit about those. AnyLogic does sometimes use them.
This
Uh-huh.
the software have somewhere in a kind of class diagram that we see the basic
Relationship of the classes?
Yeah, relationship and yeah, basically.
I mean, for AnyLogic, like.
yeah, friend. You know, what's in and
Yeah.
what's in. So have
Yeah, there are some things like that. I also have in some of my slides here some descriptions of class dependencies, like what's a subclass of what, and so on.
Yeah. So that you know when we program, so you this call that call that.
Yeah.
And you really you have understanding instead of feeling like.
So that's the
Yeah.
Java stuff, is it?
Yeah, it's the Java stuff. Yeah.
Is it part of the?
No, it turns
just
out
request-
that she identified that it's actually not on the stick, so I'd be glad to provide it if you'd
Is
like it.
okay?
Oh yeah.
That would be
Sure.
really good.
Oh no, it's no problem. Yeah, by all means, I love sharing this stuff. So
Thank you.
so there you go. Yeah.
Thank you so
So
much.
easy to give now or later on?
Yeah,
by
yeah,
mail?
sure. Why don't you give it now, because I have it up, and
Yeah.
so. Yeah, I hope it would be useful. I mean, all these tutorials I think have videos online where I explain
Yeah,
the
yeah,
material,
yeah.
and sometimes I talk
Yeah.
through additional issues between, so in other words, the slides don't capture everything I talked about in the
Yeah,
tutorial,
yeah, I
and it
know,
might.
and sometimes I go through the analysis fund if I talk about additional things.
Yeah,
So it's good to
exactly.
cross-reference
Yeah.
the recording and the slides.
Very good. Very good. No, I'm glad that
And-
could be useful.
And
Yeah.
the student copy,
Yeah.
if I teach software engineering for a class
Yeah.
of about a dozen, so what
Yeah.
kind of like
They have a
the student-
license.
Yeah.
So there's they
Is
have
it-
a form of license for a sort of a site license for educational teaching.
Yeah.
And I found it very reasonable pricing for that.
Yeah. Yeah.
I
so
think
that's enough for your say honors
Yeah.
project or final year.
Yeah, that's right.
Yeah.
yeah, that's perfectly suitable for that. And
Does the PhD student get education license?
Probably
Okay.
not the university.
um,
I think it's
I would so I'm gonna be so I'm just gonna tell you my observations,
Yeah,
okay?
yeah.
My observations is that by the strict terms of the license, that would not be considered part of the educational mandate. However, I would suggest that you, my observation has been that AnyLogic or XJTech has been reliably negotiable on issues. So if you talk with them and you discuss your issues and you discuss your funding situation, I think you'll find that you might be able to get some understanding in place. For example, maybe you want to get one.
Yeah, I will get a one dango.
Yeah.
And then
Exactly.
I will have some teachings, but
Yeah.
for some student to explore just
Yeah.
the functionalities of it.
Exactly. Yeah. I think the educational version gives you a lot to go on, and the students can end up
Get
using it for
exposure,
most of the
yeah,
interesting
yeah.
things.
Get
Yeah.
schedule exposure, and use that to facilitate system syncing.
Yeah, yeah, no, that's good. Okay, so this should be good here.
Okay, thanks a lot.
There, my pleasure. Yep. I'm
We should go have a
I'm going and enhancing those things over time, the Java tutorial. So maybe this summer I'll have another significant advance over them. I'm only sort of moderately okay with them right now, but each year they're kind of getting enriched. So probably this summer I'll do some tweaking of them and enhance some stuff. But hopefully it'll be useful. Okay. Yeah.
very,
My pleasure.
useful, very, very useful.
Very good. So Andre, you're gonna start talking at 4:30 or 4 o'clock. What's your?
Are we doing our stuff now, or later? What do you want to do? So, maybe it
Yeah.
actually depends on when do I talk to these
I appreciate that.
gentlemen.
Yeah.
So, I can do my stuff now, or I can now talk to the guys and then what would be your preference?
Probably talk with them now, and I'll do my stuff.
Okay.
And
Okay, 5
Yeah.
minutes?
David Keith is gonna help me with some mass diffusion steps, so I'm involved in
Good.
this next session.
good,
Okay.
good. That'll be terrific. Yeah.
See you later.
Yep.
You mentioned that I would like to each studies and which and I would like to first to see which one to the second one. Sort of mathematical input. Okay. What I need is to forward the second experiment after finishing the image and passing the image. So you want same sequence on the second experiment?
Yeah, but then you can just simply set the.
How you mean? You can set up this, but then I'll always have the same result each time, or I have to manually change each time I want different run again.
There's you can change the seed programmatically. And that's all the code. You can set up the seed by calling a function.
It's inside gravity, inside experiment. Sorry, I'm not understanding.
Any time of day.
You know, one thing you might want to take into account, I mean, Andre knows this well, but you may not be aware of it, is the notion of seed, okay? The notion of starting with the same random number seed, that's very useful for thinking about a particular scenario, but generally if you're speaking about a different scenario, which differs at all,
Yeah,
it really won't matter much if you start with the same
Yeah, but-
seed, except for the initial, the amount that's
yeah,
shared.
I understand, but I always have to think in the area I'm working in. It's
Okay.
cost effective.
Sure,
So what I need is two populations that are identical
yes,
until they start a different treatment.
okay.
So
So,
for that reason,
sure.
I need the C to be equal in the beginning.
Sure. So it'll set up the same network, for example, or
Yeah,
the same network,
exactly.
the same person characteristics, and then it will diverge because different things are going on.
Exactly. But
Yeah, okay.
the initial population has to be
sure.
the same.
Sure.
So
I
at the end
appreciate
of the
that.
experiments, I can get a difference between them and then have different runs of the experiment.
Mm.
How then we want difference?
Sorry?
Why would we want difference?
because with one fixed seed, one run would be just accumulating in all the quantities. Just that one case that's
Yeah, but as far as
typical.
I understand, you want them to be identical until a certain point in time, and then something different happens.
Yeah, then imagine after a certain point of time, patients start treatment A, and in the other experiment they start treatment B. But then they have to be the same, because I want to compare the costs of
Yes.
in exactly the same
Using the same
patient.
seed. Yes. Okay, and then you want.
Sure, I'm gonna have to, time is running short, but, what's the question? I may have to.
The difference, to avoid having.
Yeah.
to make it at
Oh, yeah,
extended
if you wanted to
example.
put
Yeah,
that in
one
there.
case that
Yeah,
actually
yeah,
is
yeah.
not very
So you just drag it in,
Yeah.
systematically.
Okay.
And, so, well, okay,
Yes.
sort of. So you wanna have this, right, so that they both are
so
subject to
it will
that.
be in living.
Yes, exactly. I was very tempted to do this myself as part of the example, but I decided not to bother, but, oops, sorry.
After experiment.
This guy,
Yeah,
So.
oh,
we will
Personally, no,
influence
you
here
can
that
experiment.
okay, let's just,
So there you can programmatically change seed and restart. Using this stuff.
No, no, no. That's something that starts before the
Antisol
model run?
or Excel, something like
yeah, I think that should work.
Antisol.
Oh, except, wait, sorry, this guy, first of all, you probably want the, I don't know if you're sending something to infection state chart somewhere, in which case you may wanna keep that name as the name for the whole thing, eh? Okay.
Or can I call this name like stat chart?
Well, in other words, you don't wanna not, you don't,
Hierarchy reference?
well, I think what you probably want is something like this. And then you want a, state chart, you want a initial state pointer into this guy, so when it comes into this hierarchical one, it goes to that, okay? I think this should be okay now, yeah, I think that should work.
Okay, so boss, I will check.
Yeah, we wanna go check, right, exactly.
Thank you.
Okay, yeah, good luck with that.
Initial seed run scenario 2 with the same initial seed and put this in the loop with having different seed each time. See what I mean?
Yeah, conceptually, yeah. I will have to do some looking up to see what it is.
Otherwise, in the yeah, if you want to run like 2 experiments, change seed, 2 experiments, change
Yeah,
seed.
that's the point.
Yeah.
I mean, I could do it like
Then it's either this
making.
way. Yeah.
I could do it manually, of course, and having at the beginning having the seed being written into the log, then copying it and putting it in the second experiment. But that would be time consuming. I would have to stay next to the computer for all the runs to be
Yeah.
run.
Let's say somewhere over here. There's a function that gets you the basically search. There is an API for setting up the seed.
Mm-hmm.
Maybe it's set parameter to scenario 1, okay?
Mm-hmm.
This, let's say, assuming there was a primary scenario,
Mm-hmm.
one, okay?
Mm-hmm.
One is scenario 2.
And I would just do one
And,
experiment.
Yes.
Yeah.
Well,
It has
this
to
is
be-
the experiment. Yeah. Okay. And the fail is passed to the root, so root should know which is one.
Uh-huh.
And then the whole thing, the whole thing is the loop.
The eye is definitely not clear in the diagram.
So engine get default engine generator set C
Okay.
is the unifier for setting C, and we can like, okay, run scenario 1, do something with results, save results,
Yeah.
whatever, set C to the same value.
Save seat again.
And the second one, change the seat and do another pair.
Consume.
Well, I figure till Andre comes back. And
Yeah, fine.
yeah.
Okay, yeah, I was gonna say probably 4:30 would be fine.
Yeah,
As
exactly.
a
Yeah.
plan.
Yep. Yep. That's good. Yep.
Okay.
Okay.